Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 3, Lesson number 7 on Systems of Linear Equations. Now, you saw systems of equations both in Common Core Algebra 1 and a bit in Common Core Algebra and Common Core Geometry. But today, we are going to take it to a whole nother level, because back in Algebra 1 and Geometry, you looked at what were known as 2x2 systems. 2 equations, and 2 unknowns. But today, we're going to see how to solve a system of 3 linear equations with 3 unknowns. But before we get to that more challenging topic, let's jump right into a review of solving 2x2 systems. All right, so in exercise 1, what we've got is we've got 2 systems that we're going to solve by substitution and by elimination. If you think you remember how to do this, pause the video now and take a shot at it. All right, let's go through the 2 methods. Now, we're going to be concentrating on elimination today, but we do want to remind ourselves how substitution works. If we take a look at this first, that was interesting. If we take a look at this first system, what we want to do to substitute is we want to substitute one equation into the other in order to eliminate one of the variables. Now, this is most easily done if one of the 2 equations is solved for. So in other words, there's y equals or x equals. Now, neither one of those is the case, but we can pretty easily take this equation, move that 2x to the other side where it will become negative, all right, and get this equivalent equation. We can now take negative 2x minus 7, and we can substitute it in for y, and we'll get 3x plus 2 times negative 2x minus 7 equals negative 9. And notice, kind of like elimination, we only have one variable now. Now, of course, I can solve this for x by distributing that 2 using the distributive property. I'll get negative 4x minus 14 equals negative 9. I can now combine some like terms. Positive 3x, negative 4x is negative x, minus 14 is negative 9. I can now add 14 to both sides and get negative x equals positive 5. Now, of course, that's pretty easy to finish. Either multiply or divide both sides by negative 1, and we'll get x equals negative 5. Now, remember, you are not done solving a system until you've found the values of all the variables that make the equation simultaneously true. In order to do that, we need to now take that negative 5 and either substitute it into this first equation, the second equation, or most easily into this third equation. So that's what I'm going to do. I'm going to put that negative 5 into the rule that says y is negative 2 times x minus 7. Of course, a negative times a negative is a positive, so we'll have positive 10 minus 7, and then we'll get positive 3. It's completely okay to leave your answers that way. A lot of times students will prefer to put them as a coordinate point, negative 5, 3, because that's actually the point where those 2 lines intersect each other. Okay? Now that's substitution. Let's talk about elimination. The method of elimination, which we'll be using for the rest of the day, works because you can always add 2 equations together and get a third valid equation. Now let's see what happens when we add these 2 equations together. We get 3x plus 2x, all right, no big deal, 5x, 2y plus 1y, 3y, and negative 9 plus negative 7 is negative 16. Now that is a completely valid equation, and whatever solution solved this system would also be a solution to that equation. But it didn't really do us any good because we didn't eliminate either one of the 2 variables. So what I'm going to do is I'm going to erase that, and I'm now going to manipulate one of these 2 equations using the multiplicative property of equality. I'm going to manipulate it so that when I do add the 2 equations together, something eliminates. And let's do this. Let's number the equations just to keep track of our work. I like to number them and put those numbers in circles, all right? So what I'm going to do is I'm going to take equation 2, and I'm going to actually multiply both sides of it by negative 2. All right, so I'll do 2x times negative 2, and I'll get negative 4x. I'll get positive y times negative 2, which will be negative 2y. And then I'll get negative 7 times negative 2, which will be positive 14. Now, I'm not going to do anything to equation 1 other than rewrite it. And the reason I'm not going to now, you can probably see this, is that I now have opposites, negative 2y and positive 2y. So when I add these, negative 4x positive 3x gives me negative 1x, but negative 2y and positive 2y cancel each other out. 14 plus negative 9 is positive 5, and we're now basically at this point. We can finish off the problem by dividing both sides by negative 1, and we'll get that x equals negative 5. Now we don't have that really easy, convenient one to substitute it in, so I think I'll take this moment to substitute it into the first one and just see if my y value continues to turn out to be positive 3. I hope it does. Otherwise, I made a mistake in the first problem. But we just have to work through this carefully. It's simply going to be a linear equation, typically two-step equation, but still we can all make mistakes, so let's take our time. Right? We'll get 2y is equal to a positive 6, divide both sides by 2, and here is a screen full of writing, y equals 3. Awesome. All right, so the method of elimination takes two equations, adds them together, eliminates one of the variables, and we end up with one equation with one unknown. Let me just highlight that in red, right? We added these two equations, and we ended up with this one equation with one unknown. Okay? Then we were able to easily solve that equation and back substitute to get the value of the other variable. We're going to do something very similar when we have 3x3 systems, so you really need to understand the 2x2 first. Pause the video now, take whatever time you need. All right, we're moving on. Let's do a 3x3. There it is, 3x3 system. I've already numbered the equations. Notice we've got three variables. We've got x, we've got y, we've got z. It's all good. All right, and I'm really going to walk you through this first one. So let's take a look at letter A. The addition property of equality allows us to add two equations together to produce a third valid equation. Create a system by adding equations 1 and 2, so we're going to add these two together, and 1 and 3, so we're going to add these two together, and then we're going to figure out why that was effective. So anyway, let me write down equation 1. 2x plus y plus z equals 15, and we'll do it in red. 6x minus 3y minus z is equal to 35. Now we can always add two equations anytime we want, so I'm just going to add these two. 2x and 6x is 8x. Positive y, negative 3y is negative 2y. And positive z and negative z, well, they cancel. 15 and 35, that gives us 50. All right, let's take a look at what happens when we add equation 1. Let me write that down again. I know that's a little bit irritating. Lots of writing in these problems. Equation 1 with equation 3. This takes me a little while to write it all down. There we go. 2x minus 4x, or 2x plus negative 4x, gives me negative 2x. Y plus 4y gives me 5y. And negative z and z cancel again. 15 and negative 14 is positive 1. Now take a look. What we now have, let me go back to blue, is a new system. And that new system is now a 2x2, right? Two equations with two unknowns. Let's solve it. All right, let's write down 8x minus 2y is equal to 50. And negative 2x plus 5y is equal to 1. Now, if we were really lucky, we'd be able to just add these two equations together and we'd have another variable eliminate. But that doesn't look to be the case. So what I'm going to do is I'm going to take this equation and I'm going to multiply both sides by 4. Okay, let me write that one down. Gives me negative 8x plus 20y is equal to positive 4. Then I'm going to just write this one down again. That's going to be positive 8x minus 2y is equal to 50. Now, of course, that was a particularly good strategy. We never really talked about why this was an effective strategy over here. That was because the z's canceled and left us with just those two variables. But this is now an effective strategy for the same reason. Now when we add, the x's are going to cancel each other, and we're going to simply be left with 18y equals 54. Now, if everything works out nicely, when we solve this, divide both sides by 18, y will turn out to be nice, and it does. Looks like I really like y equals 3. But there we go. Now, before we back substitute and finish this problem, let me just really explain how all these work. We take a 3x3 system, we manipulate as we need to, we add together, we eliminate variables, and we get it down to a 2x2 system. Once we have a 2x2 system, we do exactly the same thing. We manipulate equations, we add them together to get yet another variable to cancel, until we have, I guess, a 1x1 system, one equation, one unknown, right? And we solve. Now we have to back substitute, which is a little bit annoying. Okay, and I've got to find room for it. So I'll kind of squeeze it in right here. Now the first thing we're going to do is we're going to back substitute to figure out what x is. And I think I'll just put it right into that first formula right here. 8x minus 2 times 3 equals 50. So I'll get 8x minus 6 is equal to 50. 8x is equal to 56. And x is equal to 7. All right, finally we take these two and we pick an equation, any equation from up here. I think I'll just choose the first one. So then I'll do 2 times 7 plus 3 plus z is equal to 15. So we'll get 14 plus 3 plus z is equal to 15. 17 plus z is equal to 15. And it looks like z is equal to -2. Wow, that's it. Add a couple pairs together to eliminate one of the variables. Then get a 2x2, manipulate that, add together to eliminate another variable, gets you down to just one, and then solve and back substitute. All right, that's the whole idea. I mean, I could probably give many of you the homework right now and you'd be fine. But what we want to do is we want to walk you through some additional exercises and have you practice on some yourself. Pause the video now and write down anything you need to. All right, I'm clearing it up. Let's move on to another 3x3. All right, so, when you attack a 3x3 system, there's a lot of choice, a lot of things that you should think about. So what I want you to do is really take a look at this system and then take a look at A. It says which variable will be easiest to eliminate, y, and then it says use the multiplicative property of equality and elimination to reduce the system to a 2x2. So think about this for a moment and even take a little bit of time to try to reduce it to a 2x2 system. All right. Well, in my mind, the easiest variable to eliminate will be the variable y. And that's because in equation 1, and I'm going to label them now, 1, 2, it's good to label your equations. In equation 1, the coefficient of y is 1, and that's going to be easy to manipulate, right? The fact that this thing's got a coefficient equal to 1 makes it very, very easy to manipulate. But I'm going to actually erase this so that we have some room to do our work, all right? So if possible, try to find the variable whose coefficient is 1. Now, if I want to eliminate y in the second equation, then what I'm going to do is I'm going to take that first equation and I'm going to multiply it by -4. All right? Notice how I show that equation 1 times -4. It's going to give me -16x minus 4y plus, watch out for that, 12z equals positive 24. Take a look at that again. -16, -4, positive 12, positive 24. And now I'll just write down equation 2. All right, and that's going to be -2x plus 4y, there's my opposites, plus 2z is equal to 38. All right, well, when we add these two together, we get -18x. When we add these two, the y's eliminate. That's what we wanted. Add these together, we get 14z, and add these two together, and we get 62. All right. Now, it's really, really important, because this is easy to miss up front with 3x3 systems. We just eliminated y. We've got to eliminate y again, okay? We can't eliminate y and then turn around and eliminate z. I mean, we can, but it just won't get us very far. Now, the second manipulation, we really don't have to do anything at all, right? We can just take equation 1, 4x plus y minus 3z equals negative 6. And equation 3, 5x minus y minus, minus 7z, that almost looks like 7z, equals negative 19. Add together, and we're going to get 9x. See, these two just normally cancel, which is nice. I don't really have to do anything. Negative 3z, negative 7z, negative 10z, and this gives me negative 25. So there we have it, right? Let me just circle those in red. There's now our 2x2 system. All right, let me write that over here. Negative 18x plus 14z equals 62, and 9x minus 10z equals negative 25. Now we have to think a little bit, which would be the better variable to now eliminate? Think about that for a moment. Well, you can certainly eliminate either one, but I think taking the second equation and multiplying both sides by 2 makes a lot of sense, because then we'll have a negative 18x and a positive 18x. So I'm just writing that first equation down again. I'm going to have a positive 18x minus 20z equals negative 50. Now when I add these two cancel. Here, be careful, right? We'll get a net negative. Negative 6z is going to be equal to positive 12, 62 minus 50. And of course, that means z is going to be negative 2. Once we're at that point, we've really done the bulk of the work. It's all back substitution now. It doesn't mean we won't make a mistake, but it's all back substitution. So let's try to find space to do that. I think I just stick to pattern, and I'll put this into this first one. So I'll get negative 18x plus 14 times negative 2 equals 62. Just barely snuck it in there. Negative 18x minus 28 equals negative 62. Got to add 28 to both sides, right? That's going to give me negative 18x. What did I do? Yeah. Oh, of course, that's not the way I solved it. I solved it previously. Let me put this in my calculator. That's going to give me, ooh, something's going wrong. What happened? 18x minus 20z. Z is definitely negative 2. So negative 28. What is x? I'm definitely not getting the right answer here. Oh, I see why. Do you see the mistake? That's embarrassing. Somehow that negative 62 became a positive 62 there. I'm thinking to myself, boy, this is just not working out right. There it is. Sorry about that. Hey, always good. Always good to make mistakes and check our work. There we go, x equals negative 5. Whew, we still need to figure out what y is. Okay, let's see if I can do this one without a mistake. Give myself a little bit of extra room. All right, let's take that first equation. Let's do 4 times x plus y minus 3 times z. It's good I have my solution sitting next to me. Gives me negative 20 plus y plus 6, negative 3 times negative 2. Negative 6, so that'll be y minus 14 equals negative 6, and then y equals 8. Well, I stumbled a little bit there, and it's amazing what can happen when you have a positive 62 that suddenly becomes a negative 62 in the next line. That's where you want to have a lot of space to work. All right, but pause the video now and think again about what we did in order to solve this 3 by 3, because we'll make it just a little bit harder in the next problem. Okay, I'm going to clear out the text. All right, exercise 4. Solve the system of equations shown below. Show each step in your solution process. So here's what I'd like you to do. I would like you to pause the video, and then I want you to think about what variable is going to be easiest to eliminate. Then I want you to eliminate that variable, bring it down to a 2x2 system. Once you have it as a 2x2, then I want you to eliminate another variable, get it down to a 1 equation with 1 unknown, and then try to back substitute after you solve it. Pause the video and take maybe up to 10 minutes to solve this problem, okay? All right, let's go through it. Now again, the key is look for a variable that has a coefficient of 1. Now in this problem, we actually have two nice choices. We could either get rid of x because it shows up there with a coefficient of 1, or we could get rid of y because it shows up there with a coefficient of 1. Just to change things up a little bit, I think I'm going to eliminate the x. All right, I'm going to number my equations 1, 2, 3, although not mandatory, it's a good idea. So what I'm going to do is I'm going to take equation 2 and I'm going to multiply it by -4. That's going to give me -4x minus 20y plus 12z, be careful, equals 148. All right, just to make sure you understand where that came from. That's what I got when I multiplied -37 by -4. Now I'll just write down equation 1. No problem there. 4x minus 2y plus 3z is equal to 23. And now when I add these two together, the x's cancel. -22y, remember all negative there, plus 15z is equal to 171. Just making sure. After that last problem, I am not sure of anything. Okay, so now we have to eliminate the x from equation 3. That's going to be pretty easy because we're going to take equation 2 and we're going to multiply it by a positive 2. It's going to give me 2x plus 10y minus 6z is equal to -74. Again, just to make sure you understand where that came from. That was when I took that 37 and I multiplied it by 2, -37. Now I'm just going to write down equation 3. All right, that's -2x plus y plus 4z is equal to 27. And again, when I add those eliminate. I get 11y minus 2z is equal to what? Is equal to -47. Sorry about that. And there's my two equations. Two equations, two unknowns. All right, now you can probably already see what we're going to eliminate next. You could eliminate either one of the variables, but I think most people will immediately recognize that if you take this equation and you multiply it by 2, we'll get 22y minus 4z is equal to -94. All right, and again, the beautiful thing about that is that when we add these together, these cancel, the y's cancel, and we're left with 11z is equal to 77. Simple enough, divide both sides by 11, and we get z equals 7. All right, we can now back substitute to figure out what the y variable is. I think I'll just put it into here. That will give me 11y minus 2 times 7 equals -47. Really hoping for no arithmetic mistakes right now. Of course, you never know. Trying to be a little more careful here. Although quite frankly, on the last problem, it wasn't particularly an issue of arithmetic. I just wrote the problem down wrong. Don't you hate it when that happens? I hate it when it happens to my students because I feel like I have to take credit off. That's like, for me, a 1/2 point error. Yeah, that's right, I take off half points. So now I've got my z and my y. Y is -3, z is 7. Now I just got to figure out x. I think I'll take these two and I'll actually substitute them back into that equation 2 where it's just x to the first, right? That'll be easy because now I'll have x plus 5 times y minus 3 times z. Sorry about that. That didn't really turn into a negative very well. Negative 37, so that'll be x minus 15 minus 21 equals negative 37. I'm running out of room. I'm going to put it over here. X minus 36 equals negative 37. And if I add 36 to both sides, I can only imagine how small my head is right now, which is saying something for me. There's x equals negative 1. Whew! Students tend to really like these problems after they've gotten some practice with them because they really do sort of follow a very familiar pattern, right? Or they follow the same pattern each time. Manipulate, add equation, eliminate, eliminate, get down to a 2x2 system. Once you have a 2x2 system, you should feel pretty comfortable from previous courses, but again, you manipulate, you add, you eliminate, until you get down to one equation with one unknown. Then it's all about back substitution, assuming that you don't make any mistakes. All right, pause the video now, write down anything you need to, and we'll finish up the lesson. All right, clearing it out. So today, we extended solving linear systems of 2 equations and 2 unknowns to 3 equations and 3 unknowns. In pre-calculus, you'll do a lot more with systems of linear equations. In fact, systems of linear equations form the basis of a huge branch of mathematics called linear algebra, which involves both matrices and what are known as vectors. So, believe it or not, what we did today was really almost the first lesson of a whole new branch of mathematics, one that encompasses a lot of different topics and one that's used in a lot of college-level math. All right, enough for now though. I want to thank you for joining me for another Common Core Algebra 2 lesson. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.